NASA just did something they almost never do. They stopped a billion-dollar telescope, mid-mission, dropped everything to watch one object before it disappears forever. Not an asteroid on a collision course with Earth, not a supernova, not a black hole, a comet. But not just any comet, an interstellar visitor. The third object ever confirmed to come from beyond our solar system. And it's doing something that shouldn't be possible. This comet is releasing water in deep space, where it should be frozen solid, where solar radiation is too weak to cause this, where our models say this can't happen. And NASA won't say why. July 1st, 2025, the Atlas survey in Chile detects a new object. At first, astronomers think it's a standard comet. But as they calculate its trajectory, they realize something extraordinary. This object isn't from our solar system. It's traveling at 153,000 miles per hour. Its orbital eccentricity is 6.1. That's a measure of how extreme its path is. For context, Oumuamua, the first interstellar visitor in 2017, had an eccentricity of 1.2. Borisov, the second in 2019, was 3.36. This one is off the charts. They name it Comet 3I Atlas, the third confirmed interstellar object in human history. And unlike the first two, this one is about to give us a show that will force scientists to question everything they thought they knew about comets. December 2025, 5 months after discovery, Atlas passes its closest point to the Sun. And it erupts. Study lead Carey Lisse from Johns Hopkins Applied Physics Laboratory described it this way, quote, "It was full-on erupting into space, causing significant brightening, water ice sublimating into gas, methanol, hydrogen, cyanide, methane, all pouring out into the vacuum of space." NASA's SPHEREx mission, which had just launched, turned its instruments toward Atlas and detected organic molecules in the comet's coma. The Swift Observatory, using ultraviolet sensors that can see what ground telescopes can't, detected hydroxyl gas, that's a breakdown product of water. Confirmation. Atlas was releasing massive amounts of H2O. But here's where it gets strange. This water activity was detected at 3.51 astronomical units from the Sun. That's nearly 3.5 times Earth's distance. At that range, solar radiation shouldn't be strong enough to efficiently sublimate ice from a comet's nucleus. Scientists are proposing grain-driven outgassing, ice-coated dust grains in the coma sublimating, not direct nucleus activity. But even that mechanism is unusual at this distance. So why is this a problem? Because interstellar comets aren't supposed to behave this way. To understand why this matters, you need to know what happened with the first two interstellar visitors. October 2017, astronomers detect the first confirmed interstellar object. They name it Oumuamua, Hawaiian for scout or messenger. It's small, elongated, tumbling through space at incredible speed. And here's the key detail. It's completely dry, no water, no outgassing, no comet tail, nothing. Scientists debate whether it's even a comet or some kind of asteroid. Harvard astronomer Avi Loeb publishes papers suggesting it might be an extraterrestrial light sail. Mainstream science pushes back hard, but the mystery remains. Oumuamua was bone dry. August 2019. The second interstellar visitor arrives, Comet 2I Borisov. This one behaves like a comet. It has a tail. It's outgassing. Scientists are relieved. Finally, a normal interstellar comet. But the chemistry is different. Borisov is rich in carbon monoxide, much more than our solar system comets. Scientists say this tells us something about the star system it came from. Different temperatures during formation, different radiation environments, different availability of volatile ices. Okay, that makes sense. Now we have Atlas, December 2025, water active, not carbon monoxide dominant like Borisov, not dry like Oumuamua, water erupting at a distance where it shouldn't be efficiently sublimating. 3 interstellar visitors, 3 completely different chemistries, 3 completely different behaviors. Either every star system in our galaxy creates such wildly different conditions that comets vary radically in composition and activity, or interstellar space does something to these objects during their million-year journeys that we don't understand, or our models of how comets work are fundamentally incomplete. January 15th, 2026, NASA makes a decision. The Transiting Exoplanet Survey satellite TESS is going to interrupt its regular survey. TESS is a billion-dollar mission designed to find exoplanet, It follows a precise schedule, observing different sectors of the sky in a coordinated pattern that took years to plan. But in January, NASA designates a special observation sector. Sector 1751, Emergency Observations of Comet 3I Atlas. 7 days of continuous monitoring from January 15th to January 22nd. TESS doesn't do this lightly. To interrupt that schedule means something about Atlas triggered an urgent need for data. What did they see in the December eruption that made them drop everything? NASA hasn't issued a definitive explanation. They've proposed grain-driven outgassing as a mechanism for the water activity, but they won't commit. The studies are ongoing. The data is still being analyzed, and here's the thing. Atlas is leaving. Its hyperbolic orbit means it's never coming back. This is humanity's only chance to study this object. Once it exits the solar system, it's gone forever. Whatever questions we don't answer now will remain unanswered. So what does this mean? Let's break down the three possibilities. Possibility 1. Every star system creates unique cometary compositions. The temperature gradients during planetary formation, the radiation environment around different types of stars, the availability of different volatile ices in protoplanetary disks. All of this varies so much that we should expect every interstellar comet to be chemically distinct. If this is true, then Oumuamua, Borisov, and Atlas are exactly what we should expect, a random sampling of the galaxy's incredible diversity. Possibility 2. Interstellar space alters these objects, cosmic rays bombarding them for millions of years, interstellar radiation stripping away surface layers, impacts with dust grains at relativistic speeds. These comets travel through the void for eons before entering our solar system. What if that journey fundamentally changes them? What if the chemistry we're detecting isn't their original composition but a modified version shaped by interstellar exposure? If this is true, we're not seeing what these comets were when they left their home systems. We're seeing what they became. Possibility 3. Our models are wrong. We think we understand how comets work. We've studied thousands of them in our solar system. We've sent probes to land on them. We've analyzed their composition in incredible detail. But what if solar system comets are the exception, not the rule? What if the comets we've been studying for centuries are a narrow subset of what's possible in the universe? What if interstellar comets are showing us that our understanding is fundamentally incomplete? NASA won't commit to an explanation. The data doesn't fit neatly into existing models, and they're running out of time, Comet 3I Atlas, the third interstellar visitor, releasing water where it shouldn't, triggering emergency observations from a billion-dollar telescope, leaving our solar system forever. 3 visitors, 3 impossible chemistries, and no definitive answers. So here's my question for you. Which explanation makes the most sense? Is every star system so different that we should expect this kind of radical diversity? Is interstellar space altering these objects in ways we don't understand? Or are our models of how comets work fundamentally wrong? Drop your number in the comments. 1, 2, or 3. Tell me which possibility you think is correct and why. And if you want more interstellar mysteries like this, cases where the data doesn't fit the models and scientists are scrambling for answers, hit that subscribe button, because Atlas won't be the last visitor from beyond our solar system. And when the next one arrives, I'll be here to break it down. The truth is out there. We just have to be willing to ask the hard questions.